Now I'll show you what approach I had taken while doing this project. So the first step was the data collection. So as you can see in the data collection, I used the Skytrax website that was provided to us. The website looks something like this. If I click on here, it looks something like this, and it just goes directly to the British Airways page. They have given 5-star rating to the British Airways, and there are, I think there are, how many reviews? Let me check, go back and check. There are 3,418 reviews, right? So, and the other thing that I had extracted is I extracted the date when this review was posted, and um, and the country from where the customer had posted this review. Then you can go a step further, and then you can extract these data as well for each review. And I'm going to use the beautiful SUP library and requests package. So as you can see here that I have created this list, first of all, that will just be acting as columns to a data frame or to a table. And then I'll be collecting data about reviews, stars, and date, and the country. So I'm just getting that page, and then from that page I'll be getting the HTML content, then looping through the divisions and class. I'll be finding these classes and then appending those text available from those classes. So once that is done, what I'm doing here is that I'm trying to check if the length of all these collected list is similar, and if it's same. In short, if it is same, then the data frame will be created easily. If not, then it will produce an error on creating the data frame. So now I'm creating a data frame over here, and this is the first 5 entries of the data frame. We have stars, date, country, and reviews. There's you can see in the stars that there is different tabs and a new line character. So we have to do a lot of cleaning into this reviews, stars, date, and probably not in the country column, but at least the first 3 columns. And that data cleaning portion will be a separate part from this one, and this file only focuses on the data collection. Once that has been done, we will be exporting the whole data into a CSV file, and here I'm doing it as British Airline reviews.csv. So once that is done, we'll go back to the data cleaning. We'll go to the data cleaning, the initial libraries that I'm going to use, which will also include the matplotlib and seaborn for data visualization. So we are just getting the CSV file, reading the CSV file that we just generated, and one by one, step by step, we'll be trying to see the amount of the values um, generated. Now we'll try to see that we are seeing this trip verified option, and the thing is that with the trip verified option, first of all, we'll try to clean these reviews. We can create another column that will produce trip verified, um, yes or no, or true or false, or kind of binary output to that column if the trip is verified, right? So we'll create that different column, and as you can see here, this is the verified column that will say if the trip is verified or not, right? Now the other thing is that we want to clean this reviews and generate another column that will consider as a corpus for the sentiment analysis or text analysis. So what we'll be doing here is that from this reviews, we'll be removing the verified tick mark as well as trip verified options, and then we'll be removing the punctuations. We'll be lemmatizing the words, and we'll be putting that into short forms. And what also we'll do is that we'll lowercase all these words and put that into a smaller case sentences. So that has been done through this whole step here, as you can see, and corpus list has been appended with the find cleaned reviews from the customers. So that's what we have here on the last column. After that, we'll be doing some changes with the date. We will be changing the date object type to date type for the date column. Then we'll be separating the years and months as needed for the analysis. And as I said earlier, that we had this tabs and new line character columns, so we need to remove that. For that, we'll just provide a string strip method, and it will strip down all these characters before the rating. So these are the ratings that we are getting from 1 to 10, and the number of counts of those ratings from all these reviews. So that's basically that, and then we are going to check for the null values. Luckily, it seems that there are no null values in here, so which is a good thing, which is a good sign. I think most of the times handling the missing values is it's a great deal of task, because this is mostly a textual data, and we need some insight from those textual data whether what customers are really saying about the airlines. So we'll be using analytical library. We'll be using word cloud methods to see the word frequencies and such sort of visualizations will. And then I'm using the analytical library to put out the word cloud, and we can see there are these words that pop up in every comment, which is flight obviously, and then there is British Airways, and BA is also British Airways. But these words that are highlighted in larger fonts, we see that these are not actual conclusive of whether the customers are liking the flights or the company or not, or whether they are liking the service or not. So what we had to do is that we extract those. We'll consider these as stop words, and we'll add them to the list of stop words. So here I'm adding those these words, business, airlines, or we have British Airway, airline, plane, told, also passenger, all those kind of words. We're putting this into a list of stop words, so they will be ignored into the next word cloud. So now we see people are talking about seat, people are talking about food, they are talking about experience, meal, and they are talking about the crew, cabin crew, and all those things. There would also be words that are least used into the customer reviews. Then we can do the word frequency with Engram, and with the Engram we'll be able to see how these words, if joined together, are repeated how many times. For this Engram I have used the n. Okay, yeah, so I have made this number of Engrams, and I've used 4 over here. So made that function that will calculate the that will just give out the plottings of Engram words. And I can see that people are talking mostly about the business class. They're also talking about the premium economy. They are talking about the cabin crew. The cabin crew is friendly, is helpful, is attentive. I have seen that cabin crew has been mentioned a lot of times by the customers. So British Airways is doing good in terms of the service, and their cabin crew is really helpful. So I would give a kudos to that. So keep that up. But there might be lacking into something, and we'll see what they're lacking in. Okay, and what basically I'm doing here is that I decided to go with partitioning the ratings, and based on the ratings I see that if they are in range of good reviews, bad reviews, or average reviews, right? So that's what I've done, the partition the ratings from 1 to 3, 4 to 6, and then 7 to 10. So here I'm plotting the words repeated with the Engram for the reviews that are given between 7 to 10, from 7 to 10 actually. So that has been done for all the different types of reviews. And next what I'm doing is one is topic modeling, which is very close to the word cloud, but in word cloud you basically see the words and you don't see the weights of those words, you just see the size, um, and the font size different, right? But in here you will actually be able to see the weights, and you can create maybe 2 or 3, or you can also create as many topics as possible. But if you keep going down, creating many topics, your um, the number of times the common words appear will give you an idea how many times they are used. For example, in topic 1 I see flight at the top, topic 2 I see flight at the top. Going down here, topic 6 I see flight, I see flight, I see flight at the topic 8 as well, even 9, which means that flight is appearing in all these topic modeling lists. And so which means that it is used many times. It might have been used in all the reviews. All right, so this is my presentation for the British Airways, and I had tried to give out the key metrics and the insights and some of the textual information of the process, and then you just put on some graphs that really describes the way the British Airways is working. And this will give us the amount of the words that has been used in the reviews. The average overall rating is 4.84, but that has been recounted or rounded off to 5 in the website itself. So that looks something like this. We have number of passengers, trip type, flight hour, flight day, and all those information. And from that we'll be determining if the booking was complete or finished by a customer or not. So we have almost about 50,000 entries and 14 columns, and we'll be doing the data cleaning if required. While this data seems to be cleaned, it does, and this is some basic EDA done just to see how the data is spread out. So there are 50,000 entries, but amongst that there were only 7,000 values, nearly over 7,000 values that had the bookings complete, while rest of them all were bookings unfinished. So this is a binary classification data set, but it is highly imbalanced. So it's really hard to build a predictive model when there is a imbalanced data set, right? One of the first step is to one-hot encode all this categorical data. We are not going to use route. We are just using the booking origin. Well, we are not also using booking origin. We are going to use trip type, sales channel, and once that is done, then the next step will be to scale the data, because the values are not nearly same. Some of them are just binary values like this, 0 and 1, and then these are high numbers, not standard scalar package from the sklearn libraries. And then this is a correlation map. As you can see here, it's very hard to tell whether these values are affecting the output label in what ways. There is very little variation into that interdependency or correlation here. We do see that there is a good relation between, if somebody is wanting to have extra baggage, they are preferred to also ask for extra, they are also preferred to choose their seat, and they are probably going on longer lengths of flight. So that's one of the things that I had found in Insightful. And then I'm going to use train test split data from sklearn, and we'll be using the random classifier. I had used the logistic regression and produced the results, but they are not good. And random classifier also provides us to see the feature importance of each of the feature and their effect on the output label. And the metrics that we are going to use is accuracy score, F1 score, precision score, and also recall. So after training the dataset on the random forest classifier model, we have received a training accuracy of 1, precision of 1, and then F1 score of 1, which means that they are doing very good on training, which kind of defeats the idea of balanced predictive modeling. It is overfitting, as you can see here. But even though it is overfitting, is not correctly identifying the labels 100%. So the classification score here, or confusion metric score here, is just 90%. um, then we are also checking if what are the features that are really driving towards the factor of whether a person will book the flight or not. So I mean, if they will book, they'll complete the booking or not, right? So we have purchase lead, flight hours, length of the stay, flight duration, flight day. These 5 or 4 features are contributing most towards the factor whether a person would book the flight or not. So as I discussed earlier, that there is this imbalanced data sets, and why this is imbalanced is because there are more labels of 0, which is that incomplete booking, and there are less labels of 1, which is complete booking. So somehow we have to uh, work with that and see if we can maybe balance the data set or some other approaches to make the predictive modeling much more accurate. Are the final results that we are getting accuracy of 0.62, precision of 0.62, recall of around 0.58, and specificity 0.66, and then F1 score 0.6. These are very average values. I mean, if we talk about this, these are very average values. But one of the reasons that to not go forward or to not find better values than this was that we are trying to consider from business perspective. If we see, we don't want uh, to let go of the we want to make sure that the predict model is correctly predicting um, the the people who are customers who are going to finish the bookings. But they if the person is if the person who is not supposed to book, or the model is predicting for them to not book as 0, and if they are booking by somehow any chance, it is okay for us. But from a business perspective of a British Airways, if you are saying, so from a business perspective, if you're saying that the British Airways, if a customer is going to book, then they should be booking it, and the model should be able to recognize or predict that accurately. So here you can see is the confusion matrix. What this says is this is true negatives, which means that these are supposed to be 0 values, which means the customers are not going to book, and it is accurately predicting this many values correctly. And these on the opposite diagonal corner, these are called true positives, which means that the customers who are going to book and complete the booking is accurately predicted. And how many values? These are 872 values which are accurately predicted. But what our concern lies is with these 2 values on the opposite diagonal corners, which is this is going to be false positives, and this is going to be false negatives. Sorry, my bad. This is false negative and this is false positive, because this is the positive column. So this is going to be false positive, which means that they are incorrectly labeled as 0. Instead, they should be correctly labeled as 1. So out of these total values, 545 values are incorrectly labeled as 0. And here, 633 values are incorrectly labeled as 1 out of this total sum of these 2 negative values. So these values are high. Now, if whatever we try, I haven't tried other algorithms. There might be other ways to better this performance, but these are the values that we are getting. The more we incline towards the fact that we are able to identify 1, or the labels, the entries with the label 1, then our model is working very fine, and that's what I'm concerned with. and that factor is given by the recall value. So higher the recall value, will get more uh, labels which will be giving us the correct or accurate results of one. So that has been my approach. So that's why I had to stop at the accuracy of 0.62. I think it's very much important that we get the recall value better. That brings me to the final presentation of the predictive model results, and we'll also check that. So these are the final results that I have presented in the presentation, and I think you can work on providing more results as well as. So that's all from this project. I think this is a very helpful project from Forage, and there are many different projects that you can work on. So that's all for this one. Maybe next one I'll do on other project. If you have any suggestions on what information should I be sharing and what information should I not be sharing with this kind of projects, do let me know. Thank you for listening. Bye.